Asha, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss few more topics of multiple integrals, right? So let us start with the topic named double integrals in polar coordinates. So in the previous videos you have studied double integrals in Cartesian coordinates, that is over xy plane. So today we will study double integrals in r and theta plane. Okay. So the double integral theta 1 to theta 2, r1 to r2, f of r comma theta dr d theta represents the polar form of the double integration. Okay. So now this integral is first integrated with respect to r, keeping theta as constant. That is, we will evaluate this integral keeping theta as constant and integrate with respect to r first, right? And then the resulting expression is integrated with respect to what? Theta, right? So now let us solve one example. So here we have to evaluate double integral 0 to pi by 4, 0 to 1 r dr d theta. Okay. So firstly let us write our question, that is double integration from 0 to pi by 4, 0 to 1 r dr d theta, right? So firstly we have to evaluate with respect to r keeping theta as constant, right? So this will give us 0 to pi by 4 as it is, d theta as it is. Now integration of r with respect to r will be what? R square by 2. Write your limits. They are 0 to 1. Okay. Now let us start putting the limits. So 0 to pi by 4 as it is, d theta as it is. Firstly put 1 in place of r. So you will get 1 by 2 minus. Now put your lower limit, right? So if you put 0, you will get your answer as 0, right? Now what we will do, we will take out 1 upon 2 outside. So what will remain? Integration 0 to pi by 4 d theta, right? Now we know the integration of 1 d theta. It will be equals to 1 upon 2 as it is. Integration will be equals to theta. Put your limits, that is 0 to pi by 4, right? Now again 1 upon 2 as it is. Just put your limits. So the upper limit is what? Pi by 4 minus put your lower limit which is 0, right? Now simplify this. So the final answer of this integration is equals to what? Pi upon 8, right? So what we have done here, firstly we have evaluated with respect to r keeping theta as constant. Then evaluate the resultant integral with respect to theta and find your final answer. Okay, let us solve one more example. So we have to evaluate double integration from 0 to pi, 0 to sine theta, r dr d theta. Okay, so again let us start with the solution. So you are given double integration from 0 to pi, 0 to sine theta, r dr d theta. So here too, firstly we will evaluate with respect to r keeping theta as constant. Okay. So keep 0 to pi d theta as it is and integrate 0 to sine theta r, right? Now again the integration of r will be what? R square by 2 and your limits are 0 to sine theta, right? Now this 0 to pi and d theta will remain as it is. Now in place of r replace sine theta. So you will get sine square theta by 2. Suppose if you put 0, then the whole term will become 0, right? Now we will take out this 1 upon 2 outside and replace sine square theta by 1 minus cos 2 theta upon 2 d theta, right? Now let us integrate this. So 1 upon 4 will keep outside, and integration of 1 is theta, and integration of cos 2 theta will be what? Sin 2 theta upon 2, and your limits are 0 to pi. Okay, so now let us start putting the limit in place of theta, right? So firstly we will put pi. So what you will get? Pi minus sine 2 pi upon 2. If you put 0, then the whole term will go to 0, because we know the value of sine 0, that is 0, right? So now on further simplification, right, you will get your answer as what? Pi by 4, because we also know that the value of sine 2 pi is also 0, right? So this term will go to 0, and your final answer will be what? Pi upon 4. Okay, so now let us solve one more example. So here we have to evaluate double integration over r cube sine 2 theta dr d theta over the area bounded in the first quadrant between the circles r is equals to 2 and r is equals to 4, right? So you are given two circles, r is equals to 2 and r is equals to 4, right? We have to draw the region in the first quadrant, find the limits of r and theta, and evaluate the integrals, right? So firstly let us start with the solution, and let us draw the graph of two circles, that is of radius r is equals to 2. So this is the circle with radius r is equals to 2, and the outer circle is of radius r is equals to 4, right? So our region of integration is the interior of the circle between r is equals to 2 and 4, that is our this region. But we are given that our given region is in the first quadrant only, so our region R is this, right? So now let us draw the elementary radius vector OAB, that is this vector, from the origin which enters in the region from the circle r is equals to 2 to the circle r is equals to 4. Means these elementary radius vectors starts from r is equals to 2 and leaves at r is equals to 4, right? So our limits of r will be what? 2 to 4, right? And our limits of theta will be what? 0 to pi by 2. Why? Because our region is in the first quadrant only. Okay. So now let us evaluate our integration. So we will name it as I. So I is equals to double integration over r cube sine 2 theta dr d theta. Okay. So now let us put the limits. Firstly, we will put the limit of r, which was what? R is equals to 2 to r is equals to 4, right? So limit is 2 to 4 dr. Now put the limits of theta, that are 0 to what? Theta is equals to pi by 2. So we will finally get our I as double integration from 0 to pi by 2 and 2 to 4 r cube sine 2 theta dr d theta. Okay. So now let us start integration with respect to r, keeping theta as constant, right? So what will remain as it is? Integration 0 to pi by 2 sine 2 theta d theta will remain as it is, right? And we have to do the integration from 2 to 4 r cube dr, right? So integration of this term will be equals to what? R raised to 4 upon 4, and your limits are 2 to 4. Okay, and this all terms will remain as it is. Now let us put the limits in place of r. So firstly we will put r is equals to 4. So we will get 64 minus, put r is equals to 2. So you will get 4. And this integration 0 to pi by 2 sine 2 theta d theta will remain as it is. Okay. Now 64 minus 4 will be equals to 60, and integration of sine 2 theta will be what? Minus cos 2 theta upon 2, and your limits are what? 0 to pi by 2. Okay. Now let us put the limits in place of theta and cancel these two out. So you will get minus 30, and here if you put pi by 2 you will get cos pi minus cos 0. Now we know the value of cos pi, that will be equals to minus 1, and the value of cos 0, that is 1. Okay, so put these two values. So you will get minus 30 times minus 2. Now multiply these two, minus minus plus, and 30 into 2 will give us answer as 60. Okay, so this is our answer of the given double integral over polar coordinates, right? So in today's session you have studied double integral over polar coordinates, right? That is f of r comma theta dr d theta, right? And your limits will be r from r1 to r2 and theta from theta 1 to theta 2. In this, what you have to do, you have to evaluate this integral with respect to r first, right? Keeping what constant? Theta as constant, right? And then you have to evaluate the resulting integral with respect to what? Theta, right? Resulting integral with respect to theta. So from this you will get your desired answer, right? So I hope you have understood throughout the session. Thank you for watching.